All right. Well, I mean, there's like 20 some people in this class, but yeah. The only other, there's a couple people who are in person who don't come at all, like ever. And then there are people on Zoom who decide they don't want to.
Like a little tutorial on Saturday.
Sure, I'm teaching credit recovery, but I'll be here.
On Saturday?
Yeah.
Well, I need to take a week.
Which one? Okay. All right. Sorry. Thanks. Sorry about the delay. Okay, so we are going to talk about some stuff. Let's talk about yesterday's digital learning lesson. So yesterday's digital learning thing was very, very easy, but you need to make sure you do it. And here's why. There is a project grade. There is no test, no multiple choice test for this unit. What you have for this unit is you have a DBQ that we already started working on. And then you have a project. Okay, you have a project. So part of that project, like I said, I'm not going to just give it to you in one big thing and say like, good luck. Like you're going to do it part by part. So the first part was yesterday, and this project is a test grade, and it's going to be pretty easy, but you got to make sure you do the steps. So the first part yesterday, you were supposed to pick 3 or 4 things in your house that you think might be acids, and 3 or 4 things in your house that you think might be bases. And then all you had to do is start a little discussion post and tell me what those things were. That was basically it for yesterday. But you need to make sure you do that because that is actually something we're going to be looking at tomorrow. I'm sorry, Friday. Friday and Monday, we're doing a lab. Or we're doing a lab one of the days. Regardless, we're doing a lab based on that. So you need to make sure that you do that if you haven't done it. If you tried yesterday and the discussion post was not working, it's working now. So, okay. So let's talk about what we're learning about today. And I'm going to do a quick little, I'm not going to make you write these notes down because I am going to post a picture on eClass. I would still highly recommend that you spend time writing these notes down, mostly because when you write notes down, your brain remembers better. And that's kind of how that works. Your brain is like, oh, my hand is doing this. Maybe I should pay attention to what it is. So I'm going to go through these notes really quick with you guys, and then you're going to be doing a PhET simulation. Now, the good news is for your PhET simulation, you do not have to do an actual worksheet. All you have to do is it says it's under quizzes on eClass, but it's not a quiz. It's how you get your credit for doing the virtual lab, okay? All right, so this unit is about acids and bases. And today we're going to talk about something called dissociation, which we did talk about with solutions. However, it means something a little bit different here when we talk about acids and bases. So the first thing we need to do is we need to talk about what an acid is and what a base is. Now, you guys probably have a pretty good idea about what it might be. Because you guys have learned about acids and bases before, or at least you've heard the names, right? Like you've definitely heard of acids, right? You see movies and they're like, oh, it's acid. And then they spill it on a table or on somebody and then their skin melts off and the table's all eaten through and things like that. But not all acids are that way. Milk is acidic and so is Coke. And so is like the Coke you drink, not the Coke you go to prison for. Okay, so then let's see what else. Oh, soap is a base. All soap is a base. So here's the official definition for an acid and a base. An acid is a substance that breaks into hydrogen ions. We say H+ in water. So anytime that you pour like a substance into water, if it breaks apart into hydrogen ions, that is an acid. So lemon juice is an acid. If you put it in water, what's going to happen is the acid is going to break into the hydrogen ions when it's in water. That's what that means. Okay, so something you need to know is that acids are going to donate protons. That's not going to make sense yet, but it will. Okay, so acids donate protons. That's something you need to know. Bases are the opposite. So they're also called alkaline substances. So like there is a bottle of water here at school in the vending machine that says, oh, it's pH water. It's alkaline, and it's got, you know, it'll say like pH of 9 or something like that. And that's what it is. It's a base. And so it has to do with how it breaks down in water. So even though bases are sometimes called alkaline, they are a substance that breaks into OH minus. So OH minus, we call this hydroxide. I'm about to tell you how I remember that. Okay. I'm about to tell you how I remember that. So back in the like early 2000s when I was in high school, the big like thing to do was to like dye your hair blonde, but do it yourself. So it always looked really, really bad, right? Well, some of the girls who were doing that used peroxide, which is the stuff you pour into cuts, but it is also a lightener. So it can actually lighten your hair. So what I used to tell my 8th graders is that basic white girls, so base, and then basic white girls, say, oh, okay, oh. So bases right here. So your basic white girls are gonna say, oh, that was me. Not really. I was too smart to sound like that most of the time, but sometimes I still sound like that. So OH minus is called hydroxide, which kind of sounds like peroxide, which is what basic white girls use to bleach their hair. So OH minus. Okay, so hydrogen is for an acid, and hydroxide, or OH minus, is for a base. So acids donate protons, but bases accept protons. Okay, and that's right here. Bases accept protons. Here's a way you can remember which ones accept and which ones donate. Excuse me. Remember, y'all are bad. Real bad. So BAAD, bad. Bases accept, acids donate. If you get a question that says, which type of substance donates protons? If you can remember bad, bases accept, but acids donate. So bases take in protons and acids donate protons. All right. Let's continue. So dissociation means to break down. This is something we talked about with the last unit. And so what happens with acids and bases is a little bit different. So when substances dissociate in water, it means that they break down into positive ions, which are called cations, and negative ions, which are called anions. So that's what we talked about with solutions, right? That when solutions dissociate, it means they kind of break apart. When acids and bases dissociate, they're going to break down into positive ions or negative ions, or both. So the thing you really need to know about dissociation, that's what all these notes are about, is this page right here. Okay. The strength of an acid or a base is what decides how well it will dissociate. Okay. So we've got two options for strength: strong and weak. Not too difficult, right? Strong and weak. So weak acids are going to partially dissociate in water, which means only some of the acid breaks apart in water. Okay, so weak acids, think about a weak person. All right, they're only sometimes able to do part of the stuff. So weak acids partially dissociate or partially break down in water. Okay, and strong acids fully dissociate. So if you've got a really strong acid, like your stomach acid is super, super strong, really, really strong. If you were to take hydrochloric acid, which is what stomach acid is, and pour it into water, the acid is going to fully break apart in the water. Okay, so weak acids partially dissociate, and strong acids fully dissociate. The same thing applies for weak bases and strong bases. So weak bases are going to partially dissociate, and they're going to dissociate into OH minus or hydroxide ions. Strong bases, however, are going to fully dissociate into OH ions. And ions, don't forget, is just anything that has a charge, positive or minus, positive or negative, positive or minus, y'all. Okay. All right. So, like I said, I'm actually just about to post these notes on eClass for you guys. So let me show you what you're going to work on to kind of discover and talk about dissociation. Give me 1 second to pull it up. Okay. So here's our lesson for today. Please pay attention real quick. So we just did the notes. That's part 1. Part 2, it says use the simulation below to complete the assignment under assess. Well, here's the assignment under assess. This guy right here is basically your lab sheet. So what you need to do is you need to make sure you have this open so that when you're doing the little simulation here, you can answer the questions. All you have to do the simulation is click on it and it will open up. Okay. So when we do introduction, let me make this bigger. Okay. Look here, we've got a thing of water and we've got this magnifying glass here that shows us some substances. All right. So right now we have a solution that's just water. But if we click here, we have a strong acid. And look at the difference between a strong acid and a weak acid. Strong, weak. Strong, weak. Okay. Now, if we have a strong base, this is what it looks like. And if we have a weak base, that's what it looks like. So you've got some stuff to play around with. All right. And you can show the graph. You can do the molecules. Okay. You can hide it all together. I would not recommend hiding it all together. You got some tools though that you can use. So this is a pH meter. We have not talked about pH yet, but we're going to tomorrow actually. So when you have hold on. Let me show you what this little quiz looks like. It's not a quiz. It's the document that you're doing today. So like I said, you need to have this this link on this last tab open while you do this. It is not very long. Hold on. Is there a preview button? There we go. And if you just tried to access it and it didn't, now you can. All right, let me show you what this looks like. Preview. I think that's the preview button. Yep. All right, so you have 2 attempts on it, but you really probably won't need 2 attempts because the questions look like this. Which characteristics describe a neutral solution of water? So what you'll do is you will come down here, go to your solution and go to water. Okay. And then it'll ask you what it looks like with the picture and the pH. Okay. So these are the options here. What characteristics describe a strong acid? So go and click strong acid. This is very straightforward. There's no like really instructions to follow. Have this open and you're going to complete these 9 questions. That's it. With the little simulation open. Okay. And then you're done.